The F1 Ultra was, and still is, a great laser. But in just one short year, it got a major upgrade. Meet the F2 Ultra, now equipped with a 60-watt MOPA fiber laser. That means triple the power plus control over pulse width and frequency, giving you more precise engraving, richer colors, faster processing, and cleaner cuts across a wider range of materials. In this video, I asked what you wanted me to test on the F2 Ultra, and I did just that. I bought a ton of materials, including this tiny piece of sterling silver that cost me 60 bucks. I'll cover all your requests, plus a bunch of bonus experiments to see if the F2 really earns the title Ultra. Some results were expected, some were frustrating, and a few even made me wonder if the F1 might have done it better. But in the end, let me show you the results, and you can be the judge. Quick heads up, this is a class 4 laser, and safety comes first. For filming, I'll occasionally run the F2 Ultra with the lid open and safety switch disabled. That's not recommended by xTool. I'm wearing proper safety glasses rated for both the diode and fiber lasers. And you should too if you're ever working outside of the enclosure. Stay safe and always follow the manufacturer's guidelines. Alright, first, let's jump right into your questions.
Can this cut sterling silver 1 to 2 millimeters thick?
I'll be honest, cutting with a fiber laser is still new to me, and dialing in the settings takes time. But yes, I was able to cut through 1 millimeter thick sterling silver. It wasn't easy though. The kerf was so thin that it felt like the metal was holding itself together, or even maybe welding itself shut. I did manage to cut out this super intricate earring design.
That's the front side, and there's the back. Maybe I can get it to pop out. It actually does look like a pretty clean line there. And I love those colors on the back side, actually. Oh, woo! Oh, I got it. Okay. A little bit of force. It did come out.
But I had to push out every single piece manually with a screwdriver.
From this piece that's supposed to come off. Oh, yeah, there she goes.
The metal was rough afterwards and needed a lot of sanding.
After all that, we were able to get a piece that could be used.
I tried widening the cut using an engrave setting instead, and this method seemed to work way better.
Oh! Look at that! It cut!
I think the wobble setting might help with this too, since it creates a circular motion that removes more material and helps reduce the heat buildup. I was trying it earlier, but still don't seem to have the right settings yet. I'm still learning here, so if you've got any tips for cutting metals with a fiber laser, drop them in the comments. I'm all ears.
Very interested in its ability to use the conveyor to accurately engrave brass coins. I'm hoping the upgraded cameras can do a good job of centering the designs consistently.
To really test the conveyor's accuracy, I designed a circle graphic that had to line up perfectly with the edge of these silver coins. A tough job, especially since shiny objects can mess with the camera's precision. I ran it in the auto production mode, and out of the 8 coins, 1 didn't engrave at all because I placed it too far off to the side, easily fixed by repositioning it and sending it back through. 6 coins came out with great alignment, good enough to sell. 1 shifted slightly, just enough to make it unusable, because the circle was visibly off. The accuracy does seem to be improved over the past models, probably thanks to the dual camera system in the F2 Ultra. Still, I'd be cautious running expensive or one-of-a-kind items through the conveyor. There's still a little too much risk involved. A less risky option is to skip the conveyor altogether and place your items directly on the workspace using xTool's batch fill feature. It's not flawless every time, but the big advantage here is you can manually tweak the alignment if something looks off. In this example, we had 8 coins lined up, and all 8 came out with perfect alignment. So if you're working with valuable or unique pieces, this method gives you more control and peace of mind. Next up, I ran a test on some brown leather patches, using the conveyor again. And just to push it further, I even threw in a few odd-shaped items to try to confuse it. Surprisingly, the F2 Ultra was smart enough to ignore those extras and stay locked in on the patches. The results? Overall, I'd say accuracy was even better here, probably because the leather isn't shiny like the coins. Out of 10 patches, all were passable. But if you're really being picky, I'd say 3 had slight alignment issues. So 7 came out perfect, and the other 3 were close enough, but not quite flawless.
I just want to see how well it engraves stainless steel. I engrave AEBL that's been hardened, and it and all other steel I do come out rough and feel like it's been welded instead or engraved.
To see if I could get a smooth engraving on hardened stainless steel, I used this cleaver blank that Mike Smirka over at Diode Designs and I cut using the xTool metal fab. It was amazing watching this thing get cut out. It only took a few seconds. On this, I tested a range of settings. Low power gave me super smooth results, but barely any depth. Cranking up the power gave me more depth, but things started to feel a bit rough. What worked best was increasing the lines per centimeter and adding a crosshatch. I ended up using 60% power, 3,600 millimeters per second, and 300 lines per centimeter. The results had this golden tint at first, but a quick scrub with some simple green and a brass brush revealed a nice dark gray with solid depth, and it still felt smooth to the touch. So yes, with some dialing in, you can get smooth engravings on stainless steel.
My F1 takes just over an hour to do a tumble wrap. Is the F2 faster?
To test the rotary performance, I ran a full wrap design on this tapered metal cup. I maxed out the speed at just 400 millimeters per second, dropped the power to 40%, and used 200 lines per centimeter. The whole thing took 41 minutes, which is under an hour, but still way too slow for my liking. It also engraved deeper than I wanted, causing it to have a rough texture, which is not a desirable finish for a cup like this. Had I turned the power down, it would have come out much better. I reached out to my contact at xTool and asked about the possibility of them unlocking faster speeds on the rotary, and they confirmed. The RA2 Pro's rotary speed is a bit slow for the F2 Ultra's power. I don't believe it's a hardware issue. As you can see, when doing a raster on a cup like this, the rotary only has to move a very slight amount for every line the laser does with the Galvo mirrors. Theoretically, with a software update, this should be able to be fixed, but their engineers are working on improving that. Once faster rotary speeds get unlocked in the software, full wraps with a 60-watt fiber and a 40-watt diode should take a fraction of the time that the F1 is currently capable of.
Does it use their same software? Have they allowed users to start a new run by just pushing one button, or do they still need to go through a task of resending the file to do another run? Totally frustrating for any multiple runs.
Yes, xTool had this feature for as long as I can remember. Just double tap the action button and it repeats the last job you just ran. It's super handy for repeatable production runs. No need to go back into the software every time. Just tap twice and go. You can even export your laser jobs, like your business logo, to a USB drive. Then, using their touchscreen on the controller, you can pull up that file and run the job with all the saved settings. No computer needed. Just select, tap, and engrave.
Does it work with any of the previous peripherals for previous models?
Yes, older accessories like the rotary, the air purifier, the fume extractor, and the conveyor all work with the F2 Ultra. For the conveyor, you will need an updated bracket. You can request that through xTool support for now, but it should be available on their website soon as an official accessory option.
What safety interlocks exist?
The F2 Ultra comes packed with safety features. If the cover is opened, it can automatically pause or stop the laser. If the machine gets bumped, same thing. It also has a built-in flame sensor, and you can even add xTool's fire suppression system, which uses compressed CO2 to put out any fires automatically if danger is detected.
What is the actual focal zone compared to available height? Could you put a 6-inch tall item in there to be lasered, or does it need to be closer to the deck to be in the focal area?
I tested out the F2 Ultra's height range, and the adjustability is really solid. It can handle everything from completely flat objects all the way up to pieces that are 6 inches tall, and it still stays in focus.
I'm really interested in the color engraving on various materials and the colors you're able to get. With the Vincent van Gogh in the video, is that on titanium?
I believe the Vincent image shown in xTool's promo was done on stainless steel, not titanium. But I got some titanium and I'll show some colors that I was able to get with that. I tried recreating the Van Gogh using the settings that they provided for us on stainless steel. But my results came out with many different colors. I'll go more in depth on color engraving later, but just know there are a lot of variables that can affect the outcome of the colors you get in the end.
I'm also interested in how long it takes to cut thin gauge brass or steel. If you have an intricate design, does it warp?
When working with thin gauge metals like brass, steel, or titanium, warping from the laser's heat is something to watch out for. Warping will for sure mess up any intricate cutting. I purchased this clamping fixture to help keep everything flat during cutting, and it has made a big difference. Using it, I was able to get cuts on titanium, brass, and even sterling silver, like I showed earlier.
Color engraving will be a game changer? Can it engrave a solid color of your choice?
Color engraving is definitely a great way to stand out from the crowd. I've spent a lot of time trying to get consistent, solid colors over large areas, but it can be very tricky. The bigger the area, the harder it is to keep the color uniform. I'm still learning, but in the hands of someone experienced like Mike from Diode Designs, you can see he is already producing color-accurate sports logos using the F2 Ultra. Spam the comments with Mike Teach Us Your Ways and go subscribe to his channel, so maybe he will put out a video showing us how to do color engravings like him.
I would be interested in if it can accurately produce colors on metals or if it is still a bit of a guess. The demo reel seems like maybe their software has figured out the settings to produce specific colors.
The demo reel makes it look like color engraving is just a click and go, but in reality, it's still a bit of a guessing game. You want to have extra material on hand for testing, if you're chasing specific colors. That said, xTool has added a feature that breaks down color images into separate layers, so you can assign custom settings to each of the layers and build up your color engravings from there. But now, let's get into my own personal test and findings. I started off with some black paper engravings to test out the F1 Ultra speed and laser dot quality. There's a common misconception that higher wattage means lower resolution, but that's simply not true. With the right settings, even the 60-watt MOPA laser can produce incredibly fine detail. I set the dot duration to the highest speed possible, but it seems limited by the software because I'm only using 12% power. It should be able to go much faster with the 15,000 millimeters a second advertised speed. I have emailed xTool and my contact has escalated this to the team, and hopefully with a software upgrade, we will be able to run raster images like this at a much higher speeds. The laser time estimations have really improved in the software. It now shows the total job time and gives you a live countdown for the time remaining. And in my test, it has been spot on. The F2 Ultra's laser area is advertised at 8.6 inches, but I measured it myself and I was able to get to 8.66 inches, or 220 millimeters. Now that is the same work area as the F1 Ultra, but it's worth noting that most fiber lasers are limited to around 6.9 inches, so this puts the F2 and the F1 on the higher end of laser area. I wanted to run some head-to-head speed tests between the F1 Ultra and the F2 Ultra, since the F2 Ultra is advertised as being 50% faster, hitting speeds of 15,000 millimeters per second. I used the same file on both machines with maxed out speed settings. On the 1x1 scan path, the F1 actually finished 1 second faster than the F2 Ultra.
Did you see that? F1 took the lead and finished first.
Then I ran it with the scan all at once setting, and the F1 finished in 2 minutes and 15 seconds, while the F2 took 3 minutes and 38 seconds. So definitely not faster in that mode. I thought maybe this had to do with an acceleration issue and turned the F2 down to just 10,000 millimeters per second, just like the F1. But still, the F2 actually finished 3 seconds slower than when I had it set to 15,000 millimeters per second. But when I switched the setting from engraving to the score setting, the F2 finally pulled ahead, finishing in just 2 seconds, while the F1 took 5 seconds. So that actually makes the F2 60% faster when scoring. Not only was it faster this time, but the F2's quality was also noticeably cleaner and more consistent. So it looks like the F2 has stronger and faster galvo mirrors, but it still may need a firmware update to unlock that full advertised speed during engraving. To really put the camera's accuracy to the test, I taped down 5 toothpicks in different areas and drew straight lines that followed each of their angles. This is much tougher than engraving a simple word, especially since toothpicks are round, which makes the alignment tricky. After running the job, every single one was a hit. The one on the bottom right was the most off, so I updated the camera, zoomed in like a microscope, and measured with the integrated measure feature. And it was only 0.58 millimeters off, about the thickness of a standard playing card. The center toothpick was the most accurate at 0.18 millimeters. That's just the thickness of about 2 human hairs. And the other 3 were all within 0.41 millimeters, or about 4 human hairs. That's incredibly precise, especially on small, round objects like these. Deep embossment engraving on brass coins is where the F2 really flexes its power. With triple the wattage of the F1 Ultra, a job that used to take 3 hours can now be done in just 1. Woo, that's a hot... This coin I'm showing ran for 1 hour and 41 minutes, and it engraved completely through. You can even see some points here where the light is shining through the coin. I ran 6 different coins, each one at slightly faster speeds, with the quickest taking only 27 minutes. I'll show them all on the screen so you can get a visual on the depth achieved compared to the time invested. And the results speak for themselves. You can run a laser cleaning pass to finish up the coins, but I prefer using my sanding mops on a drill. This preserves the darker areas deep in the engravings and gives the surface a clean, polished look. I really love how these come out after polishing. But this time, I also tried something new: brass blackening solution. You apply it to the coin, and after a few seconds, it starts to darken. Once it's dry, you can polish it again, and the results give you even more contrast and visual depth. It also gives the coins that aged, authentic look that really makes them look great. The deepest took 1 hour and 41 minutes, then 1 hour and 2 minutes. Next was just 45 minutes and 44 seconds, then 43 minutes and 39 seconds. Even though I'm increasing the speed by 1500 millimeters per second with each coin, I think we are seeing the actual limits of the speed, as the amount of time is not decreasing very much anymore. At this point, probably doing less layers or decreasing the lines per centimeter would be the best option for faster coins, but doing that will decrease the amount of depth as well. The 60-watt MOPA tears through slate. This one was at 7,600 millimeters a second, and it took just 2 hours. The amount of slate that was removed is quite impressive. Then I sprayed it with some clear lacquer to bring out the contrast even more. I did a second one maxing out the speed at 15,000 millimeters a second, and this one took just 1 hour and 43 minutes. The depth on this one is 1.8 millimeters deep, and the first one was 3 millimeters deep. I wanted to highlight one of the users I've been following in one of the Facebook groups, William Mays. His handle is 19Patriot85. What he is accomplishing with the F2 Ultra is incredible. He takes something that is completely stock and is creating intricate patterns that are precisely placed and lined up perfectly. He is also using the power of the F2 to bore all the way through the metal, and he comments that what used to take him 6 hours on the F1 Ultra now only takes him 2 hours with the F2. Incredible work, William. Everyone be sure to go give him a follow. Titanium is also a great metal for color engraving. It reacts beautifully with the laser, producing vibrant colors when the settings are dialed in just right. I ran a test and was able to get some solid color results, but I still need to fine-tune my settings to unlock a wider range of colors. There's definitely a lot of potential here. I'll be doing more testing soon. One of my favorite uses for the conveyor attachment is creating longer engravings. Right now you can engrave areas of 8.66 inches by 21.65 inches, or 220 by 550 millimeters in a single job. I tested it by engraving this large design on a pine board using the 40-watt diode laser. The first pass only took 12 minutes and looked great, but I wanted it a little darker. So I flipped it over and ran the same job again at half the amount of speed. This time it took 22 minutes and 41 seconds, and the result was a much richer and deeper engraving. Having 40 watts of diode power on a galvo mirror system like this really makes for some quick, powerful engravings. I used the conveyor again, this time to engrave a blank aluminum road sign I picked up on Amazon. I ran it with the MOPA laser at 33% power, 1000 millimeters per second, 300 lines per centimeter, pulse width 200, and frequency 48. The job took just 23 minutes and 31 seconds, and after a quick wipe down with a paper towel and some cleaner, the laser left a clean, bright white engraving that really pops up against this gray aluminum. Even with a powerful MOPA laser, color engraving isn't quite as simple as the promo videos make it look. There are a lot of variables to dial in: power, speed, frequency, pulse width, line spacing, and all of that can be a little daunting. I ran what felt like hundreds of tests and still found myself frustrated when actual designs didn't match the results from my test grids. For example, this Van Gogh engraving turned out great, using the settings that were provided to me. But it took 11 hours and 52 minutes to complete, mainly because they used 5,000 lines per centimeter. That might be a little overkill. With more testing, I found that 500 lines per centimeter still provides solid color results and could cut that time down to around just 1 hour. So yes, color engraving can look amazing, but it takes patience, trial and error, and lots of extra material for testing. Now that's all the questions for now. If you have any more, leave them in the comments and I'll try to get to them as soon as possible. After spending a lot of time with the F2 Ultra, I can say it's a seriously capable machine. The increased power, improved camera accuracy, and ability to handle both fiber and diode tasks in one unit really opens up a ton of creative potential. It's not without its quirks. Color engraving can be time-consuming and complex, and some of that advertised speed still feels like it's waiting on a firmware update to unlock. But overall, this is a major step forward, and I'm excited to see where xTool takes it next. As always, I'm Chad from Chad's Custom Creations. Be encouraged, stay inspired, and keep on creating.